Algebra 2, Chapter 3.3, Fitting Quadratic Functions to Data. Essential question, how can you find the equation of a quadratic function to model data? And here is the standard TEACS A2.8.b. Use regression methods available for technology to write a quadratic function from a given set of data. And in this instance, I'm going to use technology, but also just outside of technology as best I can. And I'm not going to do the whole thing in this section because I don't want to have this video be an hour long. So I'm going to do a couple examples of finding from the data in the graph kind of manually estimating what a function would be to match the data, and also with the technology of the TI-84 CE calculator. Okay, so we have this data, and we have X values and Y values, and we are going to choose a vertex, and we're going to look at it, and we see we have these 2 points here where X equals 7 and X equals 8. So I'm going to go about halfway between those, and it looks like our maximum here, it says at 7, X equals 7 and X equals 8, we have our maximum of 33. So I'm going to go here to assume, and again, I'm picking this out manually, I'm going to take an axis of symmetry here of X equals 7.5. So there it is, X equals 7.5. And we're going to pick a maximum value here of 34. And so our point here is going to be 7.5, 34. And so in vertex form, I'm going to write the vertex form here first. It's going to be f of x equals a times quantity x minus h squared plus k. And what we're going to do is, when we have this vertex at the top here, we're going to say h is 7.5, so I'm going to say h is equal to 7.5, and k is equal to 34. And then we're going to solve for a and have a function and see how well that function we calculate fits these points. So we have, go from here, and we're going to have f of x equals a, which we do not know, and we're going to have x minus h, and h is 7.5, squared plus 34. So now we're going to substitute in this value for x and y, and I'm going to bring this, I guess I'll continue to bring this to the right to better ensure we have room. So we're going to have f of x, and the point we're going to use is this one down here, okay, at 3, 0. Now, that's going to guarantee that we're going to hit this point on the x-axis, but also because of symmetry, we are 1, 2, 3, 4.5 away. We're going to hit the x-axis 4.5 units to the right. So going to the right, 8, okay, 0.5, 1.5, 2.5, 3.5, 4.5. We're going to hit this point at 12, 0. And we should match somewhat the other points, maybe not here on the right side quite as well, but that's what we're going to go with. So we're going to say f of x, which is 0, is equal to a, which we do not know, times quantity x, and x is 3, so we have 3 minus 7.5 quantity squared plus 34, which is our k value. Now I'm going to continue to work below here, and we're going to have 0 equals a, and then we have 3 minus 7.5, so that's going to be negative 4.5 squared plus 34. And working to the right, we're going to subtract 34 from both sides. In fact, that's what I'm going to do here. Below, subtract 34. Subtract 34. So what we have here is we have negative 34 equals negative 4.5 squared times a. Now I'm going to work up here with this arrow. I'll say a is equal to negative 34 over quantity negative 4.5 squared. So let's just see what that is. And go to our calculator. So we go get a fraction here. We have on our numerator negative 34 divided by, we're going to put negative 4.5, close the parentheses and square that, and that should be right. Now I hope you realize that it wouldn't matter if we made this in parentheses negative 4.5 or positive 4.5, would be the same either way. So we get a negative 1.679, and that's going to be at 3 decimal places. So we'll say negative 1.679. So we know now that our equation is going to be f of x is equal to negative 1.679 times quantity x minus 7.5 squared plus 34. So that's going to be our equation that best fits as far as what we've estimated here. And so now we go to the calculator and go to y equals, and we're going to put this in place. We're going to have negative 1.679 times quantity x minus 7.5. Oops, that's not quite right. Get that. Delete that. There we go. 7.9, close parentheses, squared. And we're going to add 34. And when we graph, this is what we get. Now we should hit right here. It looks like at 3, 0, we hit that well, but we're going to get we're going to adjust our window in several respects. One, we're going to take this window here, we're going to go from x equals 0 to x equals 13, and we need to have I'm going to go from y equals, I'm going to go to negative 5. Down here, we're going to go to y maximum, I'm going to say 40. And we should be able to see what's going on here better. Yeah, we do see that. I want to do something else with the format. I want to get grid lines. Let's see what it looks like now. I think I'm going to have to adjust. Yeah, it looks like we're going 1 here, but I want to adjust by 5s on the y. So we're going to go y scale 5. So we should be able to see a lot better what's going on here. Yeah, so we have a x-intercept at 3, 0 and a 12, 0. So that looks really good. Let's go ahead and put the points in place to see how well we match the data. So to do that, we're going to go to Stat, Edit, and just enter the values. And the values we're going to use are the ones here in the table. The x values are going to be on the left column, the f of x values on the right column. So I go back over here. We're going to put in 3, 4. I'm just copying off the data here. 5, 6, 7, 8, 9, 10, 11, 12. So that's all the x data. Now the f of x data that corresponds, we have 0, comma, and we have 18, 28. Again, I'm just entering off the data from the table. 31, 33, 33, 27, 21, 13, and the last one we have is 2. And so to have it so we see this, we need to go up here in our function editor and go up to plot 1, enter that. We should see the points. And so yeah, we see the points, and we see that we hit the x-axis really well. We're sort of out of kilter somewhat for the other points, but overall, this quadratic function seems like it's a fairly decent model overall. Now, the one last thing I'm going to do is have the calculator use the data to create a line of least squares that's going to fit perhaps even better than the model that we calculated sort of manually. And to do that, we go back to Stat, and we go to Calc, and we go to Quadratic Regression, and see, I'm trying to see if I can remember what the deal is for this. Okay, regular equation. This is where I do it here. Enter. Oops. And go back here and press alpha. Yeah, okay, good. Go to the right. Okay. All right, one more. Okay, yeah, this y. Went to the right twice. Says y1. So I'm going to hit that y1 and go down, hit that twice, calculate. So here's the calculation of that, and when we go to y equals, we should see that entered right here. See that? So now we're going to see how well this fits. Graph. So this is the one the calculator figured out, as opposed, you see, it's shifted a little differently. I'm going to overlay the original one we had, which was a negative. Let me see if I can remember that here. Negative 1.697. 679, excuse me. 1.679 times quantity x minus 7.5 squared, and we're going to add 34. And we're going to see this in red. Okay, so pretty close. The red one is the one that was manually calculated. The blue one was the one the least squares method found. So technology versus the manual prediction models, very close, especially for past the vertex as we go to the right of the vertex. Very close. Okay, next, I'm going to just box this in as a, and the examples they give in the book, they have some examples of Angelique and who are they? Yeah, Angelique and Beto and Charta. And the various models they have. Now these are from the book. I think the one that I did is just as good as any of these, but I don't want to make it super long, so I don't go over all these. Okay, comparison. I'm going to go to, it says, we're going to go to another set here, and here we have this yearly average temperature problem, and I want to just pause here and have you see if you can work this out given this data, and these are the points, just like they're in a table. Okay, so you have like, these are x comma y values, so anyway, so just pause and then play ahead to see if you got anything close to what I'm getting. All right, just looking at this here, I'm not sure what'll be the best, but I'm going to assume that we have a maximum here at this value where our input value is 7. Month of 7, I guess that's 7th month, I guess that's July. These are months. So we'll say x equals 7. That's going to be our axis symmetry. And our maximum is going to be this value of 25. Let's see, yeah. Departure from average temperature, okay. So I'm going to say 7, comma 25. That's going to be our vertex. And then for a second point, I'm going to choose this one right here. This one is going to be 10, comma 1. So the standard form is going to be f of x equals a times quantity x minus h squared plus k. So now we're going to fill in with the value we have here, f of x for the vertex. So a times x minus, we'll have 7 squared, and k is 25. So now we're going to plug in this point here of 10, comma 1. So I'm going to just arrow over here. It's nice to have a little more room. So our f of x value is 1. Is equal to a, which we do not yet know, times quantity x, and x is 10, minus 7 squared plus 25. And now we're just going to solve here, subtract 25 from both sides of the equation. So we get on the left side negative 24 equals, now we have 10 minus 7 squared, which can be 3, and 3 squared is 9, so we have 9a. And so a is going to be equal to negative 24 over 9, and that's going to simplify to, let's see, we can take 3, so 24 divided by 3 is 8. And in the denominator, 9 divided by 3 is 3. So a is negative 8/3. And so our equation is going to be, our best modeling we have is f of x. I don't want to say best modeling, but it's what we model here, negative 8/3 times quantity x minus h, or x minus 7, because we said h is 7, right? X minus 7 squared plus 34. And we're going to see how well this fits the data. And so we go back to our calculator, and I'm going to, I think we can kind of use the same scale here. I think we're going up to a max of 25, but that should be pretty good actually. So we don't even have to mess with the scale. So we go to I'm going to go erase this first one here. Go down to this one here, erase that. Go to Stat, Edit, and I'm going to clear out the data here. To do that, we go up to L2, press Clear, down arrow, gone. Go over here to L1, press Clear, down arrow, gone. And so now we're going to enter the X data here, which we have as 5, 6. We don't have data for every month here. 7, 8, 9, 10. Those are all the points we have. So we only have 6 points. And then we have our corresponding f of x data, 10, 19, 25, 21, 14, 1. Okay, so we have that data. We go back here. We have plot 1 turned on. That's what the points look like. Let's go and get that equation that we determined, and that equation is going to be negative 8/3. Quantity x minus 7 squared equals 34. So here we go. I'm going to go down here. So put negative 8/3 times quantity x minus 7, close parentheses, squared plus 25. And see how that fits the data. Not so bad. I mean, it fits better on the right side than on the left side. And it has to fit this one perfectly down here because that's the point that was actually chosen. So that works out really well. Now let's go ahead and do the quadratic regression and see what we come up with. See how close that fits. I'm guessing we're going to pick up these a little closer on the left side. That's my guess. Maybe shift to the right a little bit. That's a guess. So we go to Stat, Calc. We're going to go to quadratic regression. And we're going to go down to this store, regular equation, and we press, we're trying to get it to calculate it and simultaneously put it in our, so we arrow twice to the right, and we get this y1 here, and that's going to be for equation 1. We press that, so we get that, press calculate one more time, and what it should do is it should place this calculation right where it needs to be in y equals. So there we have it. Okay, that is our equation, and that's in standard form. So let's see what the blue one looks like in this instance. Yeah, we can see that the blue one fits the overall points better, but the red one hits the maximum. And so there are like pros and cons to each, but all in all, the calculator predicted one, the blue one, is really pretty well matches this red one that I figured using these 2 points. So those are a couple examples of manually analyzing and also using the technology. I hope you're able to follow along. As always, good luck, and thanks for viewing.